All right, welcome to Mid-Latitude Storms, Lab 10. This is part 2. I'm going to start with question 11. And now we're changing how we look at stations. So instead of big maps that give us a nice big multi-state perspective of how the storm's moving, we're going to now look at how it's affecting individual communities. And we're given 4 separate weather stations: Minneapolis, Oklahoma City, Indianapolis, and Birmingham. And I did not take a picture of the page 114. So I just don't have that picture, but you guys have your books, so just reference your book when it comes time to look at those pictures. But to answer the questions, you're now going to be looking at station maps. And so, for example, question 11 asks, which station experienced the lowest surface pressure? When does this occur? And so for that, you're going to be looking at your maps, and I've already taken a look, so I know the other page doesn't have low pressures, and I know that the lowest pressure map is actually Minneapolis. So question 11, the answer would be the Minneapolis, Minnesota. And then to answer when it occurs, begins to talk about how we read these maps. And so let me go over with you how to read them. So down here at the base where I'm highlighting with my pen, this is the setup of the dates, and all of these are in the month of November. So the number in front is not the month. The first number, the 9, the 10, the 11s, and the 12s, are the day in the month of November. So this is November 9th with the 9s, November 10th with the 10s, November 11th with the 11s, and November 12th. From there, the number behind it is not years or anything fancy like that. It's time, and it's done in military time. So it's going to be done on a 24-hour cycle, which means that you're going to go from 3 a.m., 6 a.m., 9 a.m., 12 noon, to 3 p.m., 6 p.m., 9 p.m., 12 midnight. And so that's going to be your layout for the military time. So when you need to read dates, you're reading them off the bottom and everything lines up. So that means at 3 o'clock on November 9th, these were the conditions, this little line that's here. And I can tell you all sorts of information. I can tell you what the pressure is by reading this pressure line up here on that date, right? And I know that the pressure was 1,020 millibars of pressure on that day. I can tell you the wind direction on that day. That was right here, that little stem coming off, and that's done on the compass again. So this is my north, my south, my west, and my east. And it's named for where it's coming from, so it's coming from the southeast. So I can tell you the wind was from the southeast. I can also see the little bars on the back of the tail here, which gives me wind speed, and the half bar is 5 knots, right? And the whole bar, which is done on the back, is 10 knots. And the flag, if you get a flag, is 50 knots. And remember, you're just adding them up to do your knots. So I can give you the wind speeds. Down below, I can give you temperature, and the temperature I'm going to read off of this side of the graph. So I'm reading it off of this side, and it's the dark gray line. And I'm going to read dew point off the same side of the graph, and it's the light gray line on there. And then precipitation is done in bars, and that's in inches, and you're going to read it off the other side over here where it's precipitation. So I can render a whole lot of information from here, which means to finish up this first question, question 11, and determine what is the date of the lowest pressure. This is the lowest pressure on all the maps, so I looked at Oklahoma City and I looked at all the other maps that are on this page 114, and I can see that the lowest pressure is right here, right? And I can line it up and read it off my map, and I know it's lower than 180, and it's going by 20s, and I'm not quite to the bottom of the bar, so I would say 970 was my lowest pressure, and that's in millibars. So 970 millibars. And that's my question 11. For question 12, it gives you the dates, and it says from 9/3 to 10/9, by how much did the dew point increase as the maritime tropical air mass moved in Indianapolis? So for this one, you're going to flick to the next page, which is page 114, and you're going to look at those dates on the bottom that happen to line up with 9/3 and the, what do we say, it was like 10/6 or something, or 11/6, whatever it happens to be, and I'm going to read my light gray dew point lines off there. But you're getting a feel for this, and that's just how you read the map. So take your time, answer questions. Once again, be literal, give me actual numbers. And this one's really straightforward. You're just answering the questions based on the images shown. So now moving on to the next section, which is looking at a map that is at the 850 millibars of pressure height. So now we're going up in the atmosphere and we're moving aloft, and we're going to answer questions of the same storm event, so the same mid-latitude cyclone storm, and we're going to be talking about the air aloft, so the air up above. And this one you're going to be using the map, so you're circling the map, so make sure you have your book and your map to do things. And for question 18, it asks you to circle and label areas of warm air and cold air advection on the November 10th 12Z 850 millibar map. And so I'm on that map down below that they're providing me. I'm going to look for areas of advection, that is warm air advection, and areas of cold air advection. And so these dotted lines here, these are the temperatures, right? And this whole map is 850 millibars, which means all of these numbers that are written here on these solid line contours, those intervals are actually height, and it's in meters. So right here I can see that the height of the 850 millibars of pressure at the low pressure is 1,230 meters. And the high pressure system is over here at 1,612 meters. So 850 millibars is occurring at a really high height here and at a lower height here. And so now I'm going to be looking for areas where I think cold is occurring and areas where warm is occurring. And I highlighted the 0 line just to help us kind of see what's going on in the storm. And everything colder than 0 degrees is to the north of that green line, and everything warmer then is to the south. So if I'm going to highlight an area where I think there seems to be warm advection occurring, well, it's occurring in this area, isn't it? Right, where the storm seems to be rolling upwards like this, right, in this direction. And I'm going to say where cold advection would be occurring, let's say that's here, right, where it looks like the storm is going to be moving downwards in there. So I give myself a little coloration, little circle, and highlight that area, and I'll label it. And I'd say that the warm would be on this side, right, and give myself a little warm, and my cold would be on this side. Once again, I'm using a big fat stylus, so I can't write neatly. Please be clean about things. Question 19, air should rise in areas of warm advection and sink in areas of cold advection. Based on these criteria, describe the direction up or down and the location of vertical motion with respect to the surface winds and cold fronts. So on my images, I can see more or less where the storm fronts are occurring. I could see differences in height, right? So different altitudes. Just kind of give a general description, and you can use the states below. So I can say, like in the states of Georgia and Florida, I see that there's a very tall height of the 850 millibars of pressure. So it's at a higher elevation or a higher meters in height that it's occurring, and that in regions under like my Indianapolis kind of Ohio region down here where my low pressure is here, I just highlighted over whatever the number was. It was like 1,260 meters in height. So just be literal, and you can use the states below to kind of give me the answer as to what's going on in elevations. Question 20, how does the area of warm air advection and the upwards vertical motion help explain the precipitation patterns found on the November surface map? So now for this one, you're going to go back to the map on the previous page that showed you the date of November 10th at 12 noon, and just kind of tell me what's going on. You could say, like, in the states here, you could see that this higher pressures occur at a lower altitude, meaning that the lifting condensation level, or LCL, is occurring at a lower altitude. So something along those sentences, and make sure you see that. And then for question 21, we actually did that already, where we marked our 0 degree temperature line. That was the first thing I did to help me see what was going on. So how easy was that? We did that already.